A rational expression is a polynomial over a polynomial. In other words, it's making a ratio of a polynomial over a polynomial. So see example number 1 below, and you can see what a rational expression is. We're going to do different things with rational expressions, one of which is simplifying. 3 steps are shown here. Factor the numerator and denominator, that'll be step 1. Divide out the common factors. Some people call that just canceling them. State the restrictions on the domain. I'll explain why that has to happen in a minute. So let's start out by factoring the top and the bottom. We're going to use the trial and error type factoring, or the unfoiling, where you try to get this to equal. So I have factored the top and the bottom. I don't see any more factoring that could be done. And so we're going to go to step 2, which is divide out or cancel the common factors. If you divide the top and the bottom by x plus 2, these would make 1s, which means they kind of cancel out, is what we can call that. And we end up with x plus 5 on the top and x minus 5 on the bottom. And then we can say that these are equivalent, except we've got to make one extra statement to say they're equivalent, because they're not exactly the same. We have to state the restrictions on the domain. What that means is there is a value, or sometimes more than one value, that will cause the denominator to equal 0. And if you have anything over 0, that is an undefined situation. It's not possible to have 0 on the bottom. And because of that, we've got to figure out what x's would cause the bottom to become 0. And if we have any of those, we've got to say it's defined except for these values. Now, you don't want to look at the end denominator to determine that. What you want to look at is, along the way, is there anything that would have made the denominator equal to 0? It's easiest to look at it in its factored form, because then we could say if x minus 5 were to equal 0, that would make the denominator equal to 0. And if x plus 2 were equaling 0, it would also make the denominator equal 0. So what we want to do is solve each one of these. Add 5 to both sides, and we get x equals 5. Subtract 2 from both sides, and we get x equals negative 2. Those are the two places that if we put x as 5 or x as negative 2, this whole rational expression would be undefined, because it would cause a 0 to be on the bottom. So therefore, we have to say this is equal as long as x does not equal 5 and x does not equal negative 2. And that is called the restrictions on your domain. X can be anything else except those two values. So this polynomial over polynomial, or rational expression, equals this as long as x does not equal 5 or negative 2. And you have to state that with the answer. So this is the answer of the simplifying, but you also have to state the restrictions on the domain. If your rational expression looked like this, it's already factored, so we don't have to factor it, but we can divide out those two matching factors. It really makes a 1 and a 1 there when you divide top and bottom by x plus 2. And then you have the answer x plus 3 over 1, which we don't have to write the denominator anymore. And that is true for all x, except x cannot equal whatever would cause the denominator to be equal to 0, and x in this case would not be able to equal -2. So this is the answer only as long as x does not equal -2. Any of the factoring methods that we've learned in the past can be used in these rational expressions, and so for example, both of these have a GCF. We haven't done one that had a GCF yet. So the GCF of the top is 3x. If you factor out the GCF, you're left with x plus 2 in the numerator. And then on the bottom, we could factor out a 9, and we end up with x squared minus 3x minus 10. But then that can factor some more, so I'm going to write it underneath just to save space. And we get minus 5 and x plus 2. So I'm going to cross off what was there before just so you can see what the new denominator is, completely factored. And then once again, you try to cancel or reduce or divide out anything that you can on top and bottom. So x plus 2, dividing it top and bottom leaves 1's there. And then also, this is all connected by multiplication. This is connected by multiplication. So you can divide top and bottom on the 3 and the 9. You can divide them both by 3, and you get 1 and 3 if you divide top and bottom by 3. So what that leaves us is a 1 times x times 1 on the top, which is just x, and then across the bottom we have 3 times 1 times x minus 5, which is 3 times x minus 5. And it's best just to go ahead and leave it factored. I wouldn't distribute the 3 back in because when it's in its factored form, it kind of shows that you reduced everything you can reduce. And then you want to state your restrictions. X cannot equal, and again, don't just look at the denominator that is in the final answer. Look at any denominators along the way. So you can't really set 9 equal to 0, so that won't affect anything, but you can set x minus 5 equal to 0, and that answer would be 5. And you can set x plus 2 equal to 0, and that would be equal to 0 when x equals -2. So those are the things that x cannot be. You never need to worry about setting the numerator equal to 0 as far as your domain goes. And these are restrictions on your domain because domain says what x can be, and so you want to say that x cannot be 5 or -2, but pretty much x can be anything else. So it's all real numbers except for 5 and -2. Finally, I wanted to show you one special case that comes up quite often. If you have something that looks like this and something that looks like this, where they're just two numbers switched around a subtraction sign, you cannot just cancel those out. They do not equal each other. They are actually opposites of each other, and so what you have to do is this little trick. If you want to switch that to x minus 5 on the top, what you have to do is it's like factoring out a -1, and then you're allowed to write it as x minus 5. You can't just switch it without putting that -1 outside, and so that's a huge rule, and that will help you a lot. Whenever something doesn't look quite the same, you can do the factoring out of -1, and then you can switch it over the subtraction sign. Then you can take the x minus 5 that was on bottom and the x minus 5 that was on top, and you can divide them out, making 1's up here and down there. And then you end up with -1 on the top, and on the bottom you have x plus 5, and that would be the simplification of it. Also, you have to say that x cannot equal whatever would cause the bottom, the denominator, to be equal to 0 at any point during the problem, and what would cause the bottom to equal 0 would be if x were to equal 5 or -5, and so x cannot equal either one of those things, and that's called the restrictions on your domain. The domain is all real numbers except for those values.